Student, let's start with the chapter 13, that is nuclear physics, lecture 1. And in students, in every atom, positive charge, proton, right? And mass, density of mass is more at the center. It's a gravitational rule, yes or no? So positive charge and masses are densely concentrated at the center of the atom. That is known as what? Combinedly, nucleus. Yes or no? So in this chapter, we'll study the properties of nucleus. So just write, student, in every atom, right? In every atom, positive charge, proton. In every atom, positive charge and mass, positive charge and mass are densely concentrated, are densely concentrated at the center of the atom, at the center of the atom, known as what? Nucleus, known as nucleus. Correct, students? So in this chapter, we'll study about the different properties of nucleus. First, let's know atomic mass and composition of nucleus. Let's know about nucleus. That is at first atomic mass. Keep hearing. Atomic mass, atomic masses and composition of nucleus. Atomic masses and composition of nucleus. Correct. Atomic mass and composition of nucleus. Let's see about this. Students, in the previous chapter, you are having an idea about Rutherford's atomic model, right? You will be studying it from your early 9th and 10th high school classes. Rutherford atomic model gave an idea of nucleus, right? And main constituent of nucleus are what? Neutrons, protons. Yes or no? So, right, main constituents, main constituents, main constituents of nucleus are neutron and protons, right? So it is represented, friends, it is represented atomic number X. This is Z, this is A. Sometimes also we write it as X, Z, A. Correct? Yes or no? What is X? Symbol of atom. X kya hai? Right? X is symbol of atom. X is symbol of the atom, right? Z is atomic number.
Atomic number.
Z is atomic number. You know very basic things in your chemistry, but still being in physics, we'll go for something. Atomic number means what indirectly? Number of protons. Yes or no? Atomic number means number of,
Number of protons.
yes, atomic number means number of protons. That is P, small p, right? Then atomic mass number A. A is what? Atomic mass number. A is atomic mass number. Correct? It is atomic mass number. And what is atomic mass number? That is total number of nucleons, means number of protons plus number of neutrons. Yes or no? That is total number of, keep on writing, total number of nucleons. Nucleon means those are in nucleus, nucleons. So that is equal to number of protons, that is number of protons P plus number of neutrons, plus number of neutrons. You know all those things, yes or no? And,
Yes,
and what is A minus Z? A minus Z is number of neutrons because Z is number of protons. A is number of protons plus number of neutrons. So A minus Z will give what? Number of neutrons. Number of neutrons. Correctness, students? Understood? And also you heard from Avogadro's number, whatever you know about atomic mass. Let's see. Once again, in physics, I am reminding you those things. You understood this very nicely in chemistry. So next, right, atomic mass unit number, right? Atomic mass unit. You know that? What is atomic mass unit? AMU. 1 AMU is how much? 1 AMU is how much? 1 by 12 of mass of one carbon atom. Yes or no? mass of 1. I remembered or forgot in chemistry? Kirabdi, you remember or not? 1 mu means 1 by 12th mass of one atom of carbon atom, right? And that is also equal to how much? What is the mass? Avogadro's number? 1.6603 into 10 to the power minus 27 kg. Yes or no? So that is equal to how much? 1 by 6.023 into 10 to the power 23. Getting or not all? These things you know, na? Atomic mass unit.
Yes.
So let's know some definitions like isotopes, isotones, isobars, isodiapher. About this we'll learn next. Okay. So next, right, isotopes. Just giving you idea that will be isotopes. What is meant by isotopes? Student, the nucleus having same number of protons. Yes or no? Same number of protons. What is that? Same number of protons, but different number of neutrons. But different number of neutrons are called isotopes. Are called isotopes, right? For example, I'm saying, hydrogen, deuterium, or don't know?
Yes, sir.
These are three isotopes of hydrogen, correct? Just to remind you, three isotopes of hydrogen, correct? Next is isotone. Next, right? Isotone. Correct. What is isotones, students? Nuclear having same neutron, but different atomic number is called isotones, right? Nuclei, right? Nuclei with same neutron, that is A minus Z neutron number, but different atomic number, but different atomic number Z, are called isotones, right? Are called isotones. Let's take the example of isotones, right? Barium 512, carbon 612. Both are 7 neutrons. 5 minus 2, 5 minus, both are 7 neutrons, and they're isotones, right? Yes or no? Next, let's go to isobar. Orosri, what is isobar? Isobars. What is isobar? Same mass number but different atomic number. Yes or no? Right? Nuclei with same mass number A, but different atomic number, right, are called isobars. है ना? Right? For example, अगर हम example देखेंगे isobars के, very many examples are there. Just giving one. Potassium and calcium 2040. Same mass number. These are having same mass number, but different atomic number, right? Yes or no? Then another thing is there that you might not be knowing. Isodiapher, right? Isodiapher. Correct. What is meant by isodiapher? See this one. The nuclei with the same neutron, right? The nuclei with the same neutron. Proton difference, neutron proton difference. There is n minus p. These things you know, just reminding the things of chemistry, but different atomic number, right? But different atomic number, correct? And mass number. Different atomic number and mass number A, okay, are known as diaphragm. For example, thorium 90 234 and uranium 92 238. The difference between neutron number and proton numbers is how much? See, 54. The difference between neutron number n and proton number p is equal to 54. These are the very basic things in the first few minutes. You just knew about the very few things that you should keep in mind before going to start nuclear physics, right? And let some informations I would like to add here. Student, Newton was a neutron, a neutral particle was discovered by whom? James Chadwick, right? Yes or no? It was discovered by James Chadwick. What is the mass of neutron? Anyone? Kirabdi, mass of neutron? 1.6749 into 10 to the power minus 27 kg, right? Yes or no? Proton was discovered by whom? Proton, this is about neutron. Neutron was discovered by Chadwick. Proton was discovered by proton, positive charge particle, was discovered by Goldstein, right? Proton, positive particle was discovered by, right, Goldstein. Just for information, right? And mass of proton is how much? Same, na? Little difference. That is also same, 1.6726231 into 10 to the power minus 27 kg, right? And little, if you will see, mass of proton is little less than mass of neutron, right? So little less than, approximately same. And large family of isodiaphones has 0 neutrons, excess, yes or no? And after that we'll go to size of nucleus, the most important part of this lecture. Just we'll start with that. What is next, right? Size of nucleus. Give heading size of nucleus. Size of nucleus. Question used to come on this. You'll get the assignment in the form of test after this lecture. Size of nucleus, right? Students, all nucleus are approximately spherical in shape. Yes or no? Right? So all nuclei, लिख दो इसको फिर. All nuclei are approximately spherical in shape, right? Approximately spherical in shape, correct? So it has been found that nucleus of mass number A has a radius R. So we'll just write, it has been found, experimentally determined किया गया है, it has been found that a nucleus of mass number A has a radius R given as R is equal to R naught A to the power 1/3. ये expression आपको याद रखना होगा, right? You have to remember this expression. So that means R naught is एक empirical constant है. ये इसके साथ हम सारे न्यूक्लियस को मल्टीप्लाई करेंगे अगर हमें किसी का रेडियस जानना है, मीटर, ठीक है? दिस इज एन एम्पिरिकल कांस्टेंट. ऐसे ही हमने एक कांस्टेंट लिए हैं, एम्पिरिकल कांस्टेंट. मल्टीप्लाई करने के लिए अगर आपको एटॉमिक नंबर दे दिया जाएगा तो आप आराम से रेडियस निकाल सकते हैं. दिस इज द मोस्ट इंपॉर्टेंट फॉर्मूला. वी आर गोइंग टू सॉल्व क्वेश्चंस ऑन दिस शॉर्टली. ठीक है. और अगर हम डेंसिटी की बात करेंगे, इफ विल बी सेइंग अबाउट डेंसिटी of nucleus, right? So density means mass by volume, correct? Yes or no?
Yes, sir.
Density means mass by volume, correct? So that is equal to mass means mass of proton into how many number of protons, a multiply कर दिया हमने, right? A into mp. Volume is how much? 4 by 3 pi r cube, because we have considered it as a sphere. So let's take that one. So that is equal to AMP divided by 4 by 3 pi r cube. 4 by 3 is there pi, and what is radius? R naught into atomic number to the power 1 by 3 ka q. If I'll solve this one, then I'll get 3 will go top, 3 into atomic number here, 1 atomic number, and for here for q will be cancelled na. A to the power q 1 by 3 ka q matlab a cancelled. Yes or no? So that is 3 is will go off, 3 into mass of proton by 4 times of pi into r naught q. So if I will take, for example, if I'll take of 1, 3 into mass of proton is how much? 1.67 into 10 to the power minus 27. We just now found out, just told about this. 4 is there, pi is 3.14 into radius is 1.2 into 10 to the power minus 15. Empirical constant, right? That is to the power q. Yes or no? Getting, students? So if I'll solve that one, then I'll get the density is how much I'll get? 2.3 into 10 to the power 17 kg per meter cube. Understood all? If subjective question will come to find the density of nucleus, can you find?
Yes.
And you see the density of nucleus is this much, and in that formula, all the nucleus of all atoms have same density as nuclear density, and it is independent of mass number and atomic number. Understood all? Understood or not?
Yes, sir.
So let's take some examples to understand. ये जो हमने अभी पढ़े, जितने भी अभी फॉर्मूला एक दो किए, उसका कुछ मैं एग्जांपल्स बता देता हूँ, सो दैट आपको समझ पे आ जाएगा. फिर हम इसका असाइनमेंट क्वेश्चन के जरिए डिस्कस करेंगे. स्टूडेंट्स, पहला एग्जांपल पे उसने दिया है कि कैलकुलेट द रेडियस ऑफ, राइट, कैलकुलेट द रेडियस ऑफ जर्मानियम, जिसका ये 70 है, राइट? सो व्हाट इज द फॉर्मूला? What is the formula for radius? R is equal to R naught a to the power 1 by 3, na? Correct? And that is 1.2 10 to the minus 15. Minus 15 matlab femtometer or not? Fermi or no? So right here, 1.2 Fm 10 to the minus 5 ka. 70 is atomic number to the power 1 by 3. So if we will be calculating 1.2 Fm into 70 ka root q will be approximately 4.12, right? So that is equal to 4.94 femtometer, matlab 10 to the minus 5, 15. Understood all? Understood all, students?
Yes, sir.
ठीक है, तो चलो नेक्स्ट और एक एग्जांपल देखते हैं. लेट्स सी अनदर एग्जांपल. उसने दिया हुआ एग्जांपल पे कैलकुलेट द इलेक्ट्रिक पोटेंशियल एनर्जी, राइट? उसने ये दिया हुआ है, कैलकुलेट द इलेक्ट्रिक पोटेंशियल एनर्जी, कैलकुलेट द इलेक्ट्रिक पोटेंशियल एनर्जी, है ना, of interaction, energy of interaction due to the electric repulsion, between two nuclei of carbon 12 when they touch each other at the surface. When they touch each other at the surface. When they touch each other at the surface. मतलब हमें ये निकालना है, क्वेश्चन पे दिया हुआ इलेक्ट्रिक पोटेंशियल निकालना है ऑफ द इंटरेक्शन बिटवीन टू इलेक्ट्रिक रिपल्शन. दो हमने न्यूक्लियस लिए, इसका कार्बन का, तो कितना इलेक्ट्रिक पोटेंशियल लगेगा. ठीक है, तो पहले स्टूडेंट हमारा पहला काम क्या है? रेडियस निकाल देना, सो दैट हमें पता चल जाएगा कि उनके एटॉमिक डिस्टेंस कितना है. तो रेडियस का क्या फॉर्मूला है? आर नॉट इंटू ए टू द पावर 1 by 3, राइट? सो दैट इज इक्वल टू 1.12 फेम्टोमीटर इंटू कार्बन का एटॉमिक नंबर क्या है? 12 टू द पावर 1 by 3. So that is 2.52 femtometer आ गया, करेक्ट है ना? सो सेपरेशन मतलब यहाँ पर मैंने एक रखा और यहाँ पर मैंने एक रखा, तो उनकी सेंटर टू सेंटर डिस्टेंस क्या ले लेंगे, रेडियस 2r ले लेंगे ना, ये इसका रेडियस r, इसका रेडियस r, yes or no? Getting students? So the radius is
Yes.
how much? 2r. 2r को अगर multiply करेंगे तो 2 times of 2.52 is how much? 4 point, not 4 point, that is exactly 5 point will be there or not? If the class ends region, same ID region 5.04 femtometer, correct? 10 to the minus 15. So अभी हम क्या निकालेंगे, इलेक्ट्रिक पोटेंशियल एनर्जी निकालेंगे दोनों चार्ज पार्टिकल का। तो इलेक्ट्रिक पोटेंशियल एनर्जी का क्या फॉर्मूला है, k q1 q2 by r ना, yes or no?
Yes, sir.
k q1 q2 by r. So that means 1 by 4 pi epsilon naught into दोनों का चार्ज q1 q2 divided by r, yes or no? So what is the value of constant? 9 into 10 to the 9, correct? Into charge is how much? 1.6, 6 इलेक्ट्रॉन है कार्बन का, करेक्ट। एक का 10 to the minus 19 6 टाइम्स हो गया, दोनों का मल्टीप्लाई करेंगे तो दोनों का स्क्वायर हो जाएगा, है कि नहीं? चार्ज 6 इलेक्ट्रॉन्स आर देयर इन कार्बन और नॉट, तो 6 into 1.6 into 10 to the minus 19 स्क्वायर, और नीचे रेडियस क्या रखेंगे 5.04 into 10 to the minus 15। तो जब इसको पूरा सॉल्व कर देंगे तो आंसर आएगा 1.64 into 10 to the minus 12 जूल। So that is equal to 10.2 मेगा इलेक्ट्रॉन वोल्ट, अंडरस्टूड? अगर 9.1 से डिवाइड करेंगे तो इट विल बी 10.2 मेगा इलेक्ट्रॉन वोल्ट।